Hello everyone, welcome to my channel Cloud and Data with Koshi. So today we are going to discuss the data wrangling concept from the previous session, right? So we have already seen some kind of use cases and what is the demo and what is the use cases that already have discussed, and some parts of data wrangling I have already covered. And now from the rest of the things I will continue from there, right? So without any delay, let's get started. So before starting the session, please let me know that I am audible to all, right? Okay. So my screen is also visible and my audio is also there, right? Now we are inside our Jupyter notebook, right? In the Google Colab environment. This is my Google Colab environment, and this is the last part. I have done the observation part, right? Now, what I'm going to do, I will check the percentage of rows with the missing values. So I'm writing, let's check the percentage of the rows with missing values that I'm going to check. So also I'm writing here, we are performing the operation to determine whether the NA value rows can be dropped off or not, so that we cannot deviate from our desired model. Okay, that I'm going to check. So write percentage of missing value is equal to, I already have my final data, right? And atemp, ATEMP dot is NA and dot sum, where my axis is equal to 0. Okay, by final underscore data dot shape 0 into 100. So we are going to calculate the percentage, right? And once it is done, right? So please consider on the cell. So once it is done, this value will be stored here. So my final data, and inside that this one column is atom, right? You also see this thing. So just take one cell, so final data, and you also see atom ATEMP. So this is the column inside the final data. Okay, and what I'm going to do, take the isNA method and taking the sum, right? And once it is done, I can divide it with the same 0, right, into 100. So then you will get the missing value over there. Just run it. So you can see that this is the percentage of missing value, right? This is the percentage of rows, percentage of the rows with the missing values. And what the observation, now I'm going to add the observations. So write observations. So first we divide the number of null value by the, what I'm going to do, by the shape of the data frame to get the percentage of missing values, right? First, we are going to perform this step. Second step is what? Since the percentage is 1, that means it is very less. So usually the industry practice allows us to drop. So there is the standard practice, right? To drop rows up to 30%. So we can drop the rows with missing values. That step we are going to already perform, right? So this is two observations that we have already seen, right? This is the observations. Next, we can drop the rows with missing values. Next task is that drop the rows with missing values. Just select it. So what we are going to do, we will use the drop NA method. Drop NA. Okay. Drop NA function to, you can say, write drop the null values rows. Okay. That we are going to perform here. So you have the final underscore data, right? And you have to take final underscore data dot drop in A. Okay. And this axis should be 0. Now, before going to drop, just check the shape dot shape. So there is 1000 column rows and 16 columns, right? There are 1000 rows and 16 columns are there. Okay, and we can drop in a method for drop the rows with missing values. We can write drop the rows of the missing values. Now execute the cell. After that, we are going to check its shape again. To check its shape again. So final data, final underscore data dot shape, right? If you hit the enter, so you can see 989. That means 11 rows has been dropped out. So we can compare that 11 rows has been dropped. Okay. So I'm writing the observations for that. Observations. Right. What I'm going to perform, that I'm add the observation. So we can, first observation, what? We can see that the shape of the data frame reduced, shape of the data frame reduced to 989, right? That already shown from 1000. Previous 1000 was there. It shows the, you can say that missing value. So every step I'm going to add over here. So you can understand properly, right? You can understand this properly. So it shows the missing values rows have been wiped off. Wiped off. Okay. Next observation is what? In further lessons of this assignment, or you can say of this demo, we will see the different methods. So we will see the different methods to treat the missing values, right? To treat the missing values. Okay. Once this demo will be progress, or in the further session, that we are going to see more methods to treat the missing values. So you have to count it, right? Next task is that, what is my next task that I'm going to add? Now let's check again the missing value count. Missing value count after the drop. After the drop. That we are going to see, right? That we are going to see. So please let me know up to that, is there any problem or anything? So otherwise we'll continue. Okay. So if you have any problem, any doubts, so please let me know. So everything will be clear cut to your mind, right? So you can understand the concept properly, right? Now what I'm going to do, final underscore data dot is na dot sum and axis is equal to 0. Okay. So we see that there is no missing values. There is no missing value after the drop. So 0, 0, 0. Okay. So that means there is no missing values. So you have to perform the sanity check on the data set. So next task is that. So next task is perform sanity checks on the data set. So that is my next task. We have to check, we have to test it, right? So I'm also write that one heading. So check if casual plus registered is always equal to count. That is my task. Okay, this is the sanity check that I am going to perform. Okay, so write NP. So if my font is not visible or the screen is not visible, so I increase the size. Now you can properly understood, right? NP dot sum. Okay, final underscore data, and you have casual. This is the column name, right? Plus final underscore data, and other is registered. You can see registered. Okay, registered is there. Minus final underscore data count. Okay, so you can check is there any equal count or not. So 0 will become. So you can see 0. That means my sanity check is working properly, right? So on this data set, we have to check if casual and registered is always equal to count. So this is the funda, or this is the syntax. You can write np.sum, np.sum to accumulate or aggregate the count. Okay. First sanity check. I am also right. First sanity check. Copy the enter thing. We have to perform other sanity check always also, right? So you have to just, and you have to write. So this is my second sanity check. So month values, should be in the range of 1 to 3. That is other task, right? That is my other task. So just check it properly. Now take one quote in the cell, right? I hope my screen is visible so everyone can understood. So write np dot unique, np.unique, okay, and you can write final underscore data dot month. So it will return the array, right? Unique array. You can see, yes. So 1, 2 that will return. Next task, task number 3 for that part. Hour should be in the range of 1 to 24. Inside the range of 1 to 24 hours, right? So that range should be there. So select it. Yes. So okay, so step by step I have discussed, right? So if you feel that I'm going to fast so many fast, so I will control that speed. And once you all can confirm, right? Then this speed I will maintain in the entire session, right? So third task is that hour should be in the range of 1 to 24. So write np dot unique and your final underscore data dot hour. Same method, np dot unique and final data dot hour. Okay, so you can see the array is coming for the hour. So 0 to 23, that means it is right. So inside this range or inside this bin, the value is there, np dot unique. So you can write numpy. It's a numpy method, right? np dot unique. So with the help of unique method, we can perform this task. Unique value should be prepared and the np dot unique value should be prepared for that. Okay. Now we have to print the statistical summary of the data. Next task is that print the statistical summary of the data. Okay, this is my other task. Very simple comment that I'm going to add over there. So I also add the statement. We will use the describe. Okay, describe is one method. The statistics, the statistical summary, getting the statistical summary. So you have to add the describe function or method to see the statistical summary of the data set. Okay, so we are going to add. So write print final underscore data dot describe. Okay, so you can see the statistical summary, 5-point summary. You can see that count, mean. So instead of print, na, you can also use this way. So the data frame will be maintained, right? So you can see count, mean, standard deviation, mean 25 percentile, 50 percentile. So entire value should be there, right? Any problem? So you not understood anything. So I'll take, I'll just hold 1 minute. So if you have any doubt, so please let me know. Otherwise, we'll continue. Okay. So now we already have discussed this thing. So I also add this node. So we already have covered many concepts, right? Like the data wrangling. Now we have to see the explicitly outlier detection. we have to see how we can detect the outliers and how we can remove them. So I am writing this note. So we have seen almost all the methods of data wrangling. And now let's see explicitly outlier detection and removing, right? That we are going to perform with the next task. So as of now, we have done most of the things. We have to import the libraries first. Import the libraries. Okay. So apart from the pandas, I'm writing all the statement over here. So apart from the pandas and numpy, this time we are using scikit-learn. This time we are using scikit-learn. Okay, so first we have to see the official documentation of scikit-learn. Okay, so this is the official page of scikit-learn.org. So everything is mentioned over here. So this library we are going to use as of now. Okay, so you can see it is using for classification, regression, clustering, model selection, pre-processing, dimension reduction. So every each concept we are using the scikit-learn method, right? So you can see the API example, right? I'm going to see the example. Okay, so the code is already there. Okay, so right, I'm clicking over there. So they will demo that how we can install with the pip environment, how we are installing the conda environment. So everything, every details you can get from the scikit-learn.org. That means that is the official website of scikit-learn. Okay, so just copy, and I mentioned this is the official page. You can explore for getting more knowledge from there. Okay, so scikit-learn, or short form is sklearn, is an open source module that has some inbuilt data sets. So here you can see that sklearn library, there is inbuilt data set that I already discussed, but now again I am telling the same thing. The sklearn library has is inbuilt data set, right? Like we are not going to add the CSV file for the data set. It has own data set. Okay. Third, you can write each data set has a corresponding function. Okay. Used to load the data set. Load slash iris, load slash breast cancer. So this is all that I'm going to show you. That is not the issue. So I'm going to add whatever we need to discuss, right? So this function follow the same format. Load underscore data set that I'm going to use over there. Load underscore data set. Remember, load underscore data set is a method or function to using for using the purpose of loading the inbuilt data set value. Okay. So where data set refers to the name of the data set, and if we are importing two data set in this demo, right? Two data sets. We are importing two data sets from sklearn. I'm writing because you all can understood each and everything with step-by-step procedure. So you can understood the concept, you can understood the syntax, everything. So I'm going, before going to apply, I'm adding all the things, right? So we are inputting two data sets from the sklearn dot data sets. Okay, in the cell below. Okay, so we have to import numpy. Already we have imported in the first section of this same file, but for getting the each block at a time, so I'm going to add again. So everything you will get inside this block. That is the reason I'm going to add this thing. Import numpy as np, import pandas as pd, and from sklearn. So I'm going to write this thing for using the data set. So this is the syntax. So from sklearn dot data set, you have to import two data set. First is load underscore iris data set, and other one is load underscore Boston. TON. So these are libraries that we are going to add. Okay. Okay, this is removed. So I am going to only load the iris data set. No issues. Right. Import the necessary libraries. So we can see that from this inbuilt data set is removed, right? From scikit-learn version 1.2. So what we are going to do for the solution? So we just remove this line and we can add this line. Okay. So from the OpenML, that is one libraries we are using for fetch the Boston library over there. So just load it. So you can see the data, every library, everything is added. So import, you can write this thing, import the necessary libraries. Okay. Now you have to comment out this thing and load Boston data. Okay. So our two data sets are loaded. So I'm adding the observation over here. Load the data, and since I'm writing the statement, since these data sets are directly importing from scikit-learn, okay, the load functions such as load underscore Boston. This is the dataset name. Do not return data. Do not. But here I am using the OpenML, that fetch OpenML libraries. Do not return data to the in the tabular format. In the tabular format. Okay. And we also seen that from sklearn version 1.2, the inbuilt load underscore Boston is removed. So instead of that, we are using fetch underscore OpenML, and alternatively we can load this data set. Okay. Hard point, the data is stored in the form of keys and you can say write words and values. Definition like the dictionary structure. Okay. Fourth point, let's load the data set and store it in a variable that is called host. Okay. Fifth, now we are going to call the keys for the Boston data set. Okay. So these are the point we already seen, or we are going to discuss the this next means in the upcoming data point, right? So this is the point we already seen. We already load our Boston library, right? Like if you have add print Boston dot is so here I think we are using the fetch email. Just a minute. The this will not be adding Boston underscore keys. Yes, you can see it's there. So dict key data target frame. This is the values, right? Yes, yes, keys is very common. So you can get the keys, dictionary dot keys, and your like data target feature names, everything is available for the Boston dataset. Okay. Now we have to do next task, that is find features name. We can write find feature name. Okay. You have to find the features name. So like you can write X Boston dot data or data Y is equal to target. Okay. So your feature name like X and Y is there, right? And you have to add the columns. So feature name X and Y we can grab from Boston dot data and dot target. Okay. As of now, is there any confusion? No, right? Now you have to add the columns. That is Boston dot feature names. Okay. And you will get the columns. You will get the columns inside the Boston dataset. So you can see this is the columns name are coming, right? Now we have to description of the dataset. Next task is that description of the Boston data set. Okay. So very simple comment, that is not worried about this, like print, and you have to write Boston dot descr describe. Okay. Description, not describe. So description is there. So you have to download from the openemail.org. All the things is there. So if you explore openemail.org also, just hit, and this is the official website of OpenML. Alternatively, the libraries and all the other stuff that we are going to perform over there. So you can add your data set. You can see a worldwide machine learning lab. So you can also perform the machine learning task over here. So I there is another sessions, means we have we in the future sessions we are discussing the OpenML part. That's not a very big deal. So I will discuss all the things over there. Okay. So as of now, we are okay. And so I will not cover in this session. So you can get the different session for the OpenML, and I will discuss all the details of the OpenML part. no issues. Okay. Now next task, let's convert the array to a data frame. Very important concept. If you have array and you have to convert it, that means tabular structure structure. You have to convert in a tabular format. Okay. So you have to write since both data and target x and y are, you can see na, x and y is print in the numpy array. You can see print your x, okay, and you can also print your y, okay. You can see, and also you can print the type x, and you can also print type y, okay. See the effects. Pandas data frame, right? Both target are in a numpy array. We need to convert it into data frame. That is my task. So we have the Boston underscore df means data frame, and pd dot data frame. Pd dot data frame is inbuilt function. You can see it's an inbuilt function. So it will take the parameters two-dimensional size mutable potential heterogeneous tabular data. So data, you have to pass some data and it will convert in the data frame. So you just hover over there and you can get the every details of the data frame, right? And you have to write Boston dot. Now it's loaded. So I will add other like all the code and then I will execute at a time. Okay. Boston underscore df dot, that your columns name. That columns you will add from there, these columns, right? We have already added the columns, right? Boston dot features name and it will return. I'll add Boston dot feature underscore names and it will return the columns. Okay. I hope I am clear. Columns, and then you have to add Boston underscore df and you have this column. Okay. Just print now Boston df. Here you can print dot, what will come, and you can see the data set, right? And we will create MEDB this. I will add this frame and you have to is equal to y. So you have to add your y means what? Y means your target. Target you have to add, okay? You have to add the target value. You have to add, you added the target value in the new column MEDV. Okay, and next Boston underscore DF underscore O is equal to Boston underscore DF. And you can print this value like Boston DF and save means to check how many rows and columns are present. Okay, and next you can print this value df dot save. Let's execute the cell and you can see 506 rows and 14 columns for both the data set, right? Add the value 506 comma 14 and here also you will get this value, that is 506 14. 506 is our rows and 14 is our columns. I hope you can understood these things, and next you have to take the observation part. Observations. Boston underscore DM, okay, has already seen, already known, and just write it. 506 rows and 14 columns. Okay, my observation is done already. Yes. Now I have to describe means 5-point summary. You check, you just you have to remove and take the coding cell. So to check the 5-point, you have to print Boston underscore df dot describe. Okay, and you will get the value mean, mode, median, 5-point summary you can collect from there. And first 5 rows, you all know all these things. To check the first 5 rows, you can write Boston underscore df dot head. First 5 rows you will collect. Now, very important concept, that is outlier detection. So make one heading, outlier detection. Okay, you have to perform univariate, means one column univariate, and using the box plot. Okay, please concentrate on this part, that is very important, and that I'm going to discuss or making one code. So also write the context box plot. What is box plot? Box plot is a graphical method for representing the values in the data. It shows how the values are spread and skewed. Okay, that I am going to check. So load step by step. We are going to discuss it. Load the box plot with Boston underscore df. Write Boston underscore df dot box plot, and we are executing this cell, right? Just a minute. You can execute this cell. Once you execute, you can see these values are coming, right? This box plot is creating. So what is my observation that I'm going to add over here? Observations. Since the values are different from each other, okay, so that is, it is not right to put every column. It is not right to put every column in the same scale of measurement, in the same scale of measure. Okay, we cannot use the same scale of measurement for observing these values, right? So let's, you have to import. Let's import the libraries like matplotlib, and on top of that we can use cbond. Okay, so we can write matplotlib is a data visualizing and graphical plotting library. Plotting library for Python. Okay. And C1, what is C1? C1 is also data visualization library built on top of the matplotlib, which is used for making statistical graphics and which is used to is for making statistical graphics, that we already know, right? That's these two libraries we are going to add, matplotlib and cbond. Both are data visualizing and graphical plotting library. Okay. So write import matplotlib dot pyplot as plt As means alias. Okay. So matplotlib.pyplot as plt. You have to import this matplotlib library. Import matplotlib. Okay. Libraries. Next, you have to import the Cbond. Import Cbond as SNS. Okay. And you have to write matplotlib and SNS dot box plot x is equal to your data. You have to provide posture underscore df. This value will be your DIS. Okay, and just run this cell. Now you can see this is my DIS column, and this some outliers and all the details are there, right? And you can see this thing, right? And you have to use next task is that IQR. You have to use IQR. You have to calculate this, right? IQR full form is inter quartile range. It's a technique for outlier treatment. Okay, we have to perform this task IQR. We have to create one function outlier underscore treatment. And you have to take the column name and you have to short it your column and Q1, Q3, and you have to use np dot percentile. Okay, and you have to provide the column. So I'm going to use one function and for the outlier detection, right? So call and you have 25,75. Next, IQR is equal to Q3. Okay, take on capitalize this thing Q1. So Q3 minus Q1 and lower range Q1 minus, we already know 1.5 into IQR, and upper range is equal to Q3 plus 1.5 into IQR, the upper quartile, right? And you have to return what? Lower range, comma, upper range. So this is my simple function of outlier treatment, right? For detecting detecting the outlier. And we execute the same. Okay. So what is my observation? That I'm going to add observations in this technique. We divide our data set under percentiles like your 25, 75 of percent. Next, after that, we find the IQR. We find the IQR between these two percentages. Two percentages. Okay. And next, now to remove the outliers, the outliers, we calculate the lower and upper range by using the formula. Given formula. Okay, I hope we can understood. So we divide our data set into 25 and 75 this percentage of a sample, and then we are calculating the IQR between those two percentage, right? And all the values which are beyond this range are considered outliers. Okay, and must be, and we all know outliers positive or negative that can disturb the normal flow of your data. Hence, we should remove that. You have to remove it. Okay, so write lower underscore range and upper underscore range is equal to your, you have to call this function outlier treatment, and you have to pass the data set. Which data set I am going to pass? Boston underscore DM, and you have to pass the this. Okay, so your lower range, upper range will be calculated. And you have to print lower range and that will be your lower underscore range. Now you have to print upper range upper underscore range. Okay. Let's take a look. What will the value? So you can see lower range and upper range we are calculating, right? So we have the observation. Again, I am going to add my observations. Observation. Please follow this all the steps so you can understood the concept. So this is my observations. So we have calculated the lower and upper ranges for DIS, okay, feature of our Boston underscore, okay, and next we have to create the data frame for lower and upper range of this data set, like the lower Boston underscore DF is equal to what? Boston underscore DF, and you have DIS dot values that is lower, right? You have to compare and have to add this lower underscore range. Okay, and you have to take a look on that. So you can write and you have to print this value. So something is missing at 1 minute. 1 minute, I have missed something. Yes, now you can check. Now you can check. And you have to check the upper range also. Now we can check the upper range also. So you can write upper underscore Boston underscore DF and just copy this thing. Copy and paste here, and you have to write upper range. And you have to print this value so you can get the idea. So we can see there are no rows in the lesser, means in the lower category, right? In the lower Boston DF there is no data, and but upper you can see the data, right? So I'll add the observations. Add my observations. There are no rows that are lesser than the lower range. But there are 5 rows that are greater than our upper. Okay. Now next task is that you have to get the outliers. Lower underscore outliers is equal to you have this data set, right? Lower motion underscore df dot value underscore count and dot you can use sum and your axis is equal to 0. Just copy this thing and paste. That is your upper outliers. To check upper Boston underscore df dot value underscore count dot sum axis is equal to 0. And you have to calculate this lower outliers and upper outliers, and you have to get the total outliers. Now you can get the total outliers. So you have the lower outliers plus you have the upper outliers, and you have to print. So there are number of outliers like 501, the upper side. And you have to take the one observation part. I'm writing this thing. Observations with the given code, we are summing up the total number of outlines. Already seen this thing, right? Now let's new another task is that you have to list down the row numbers that contain outliers. So you have to, the task is list down the row numbers that contain outliers. Lower index is equal to your list method you have to take. Boston underscore df and you have Boston underscore df and it's BIS. And you can write lower underscore okay, and you have to get the index position dot index. Copy it, paste, and you have the upper index. upper index, you can use this only change. Okay, and your total index will come. Total now you have to add the total index. So you have to list, put in the list and simply add the lower index plus your upper index value. And you have to print the total and yeah. So 351, 352, 353, these are the row numbers where your outliers are there, right? And now you have to drop the outliers row. So we can drop the outliers row. How can we do that? So we can write print and save before dropping outliers. You can check save before dropping outliers row. That can be your Boston underscore df dot. Now you can check 50614 rows, right? And now we are going to add it. The code which is remove the outlier Boston underscore df dot drop and your total index total underscore index comma in place is equal to true. In place true means it will be affected in that data frame, right? And something is working over there, so drop and now okay, just take this yeah, and you can write save after dropping, not before. After dropping outliers row, and you can see the shape will be changed. 4 rows 1 2 3 4 5. So 506 minus 5, that means 501 rows. That is calculated. And observations already told, but I'm going to write as of now. Observations in this given code, we check the shape of the data set before before and after dropping outliers row, dropping outliers rows. Okay. Next, you can see that the rows so you can see the rows before dropping the outliers were 506, and after dropping the it became 501. Okay, thus we have successfully dropped the unwanted rows. Unwanted, that is not required. Next task is that we have to check the mean value. We have to check the mean value. What I'm going to write? Print Boston underscore df dot mean. So you can see the mean values of each and every rows that is there, right? We can calculate the mean value. Now we have to check the skewness. Now we have to check what I am going to do. Now we can check the skewness of the data. Skewness of the data. Is there any problem to not, if anyone not understood this thing? So please let me know. Okay, so we have to see what is skewness. So skewness is a way of checking the outliers. Position in the data set. So that is the reason skewness is there. So it check the outlier position in the data set. If the data is right skewed, it means that most of the outliers are at the right of the distribution and vice versa. Okay. What are we going to do? Boston underscore df and dot skew. Skew is one method. It will determine the skewness of the data. So you can write axis is equal to 0 and skip NA is equal to 2. So the skewness will be showing. So you can see the skewness of each column that is there, right? So the default, you can see the future value of numeric only in the data. Skew is deprecated when future version will default to false. In addition, specifying numeric only one is deprecated. Select only valid columns or specify the value. Okay, so our skewness is there and we can plot the skewness. Now we can plot the skewness. You have to plot it. what I'm going to do, Boston underscore df dot skew, okay, and axis is equal to 0, comma, skip na is equal to true, and you have to plot it, dot plot plot. So you can see one graph will be created with that skewness graph, right? You can see here you will get one chart, and our charts are coming, right? Okay. So as of now, we have discussed the skewness of the these observations and the outliers, all of the very important concept, right? And with the how to load the Boston dataset, how to load the IDs dataset. So in that session, we have already covered these things, right? The next session, we are going to discuss some more concept like correlation, Pearson correlation. There are many more concepts are there. So we are going to add the coefficient part. Okay. So if is there any problem or if you not understood, so please let me know. So otherwise we can drop, we can close the session. So thank you everyone for participating the session. If you have any queries, so please let me know in the chat or in the comment box so we can address your concern. We also know the OpenML libraries over there, right? And please subscribe my channel, and with that we can learn and grow together. Thank you everyone for participating it, and please subscribe it so we can learn and grow together. We can also learn new things, new concept. Thank you for joining the session.